Okay, we're recording. I will put the tape of this session and all the other sessions, as long as I remember to record them. I'll put them up on YouTube and I'll link them. I'll put links to them on this website and also on the Discord server. So anybody that wants to see the video, go back and look at some material, someplace where I was unusually obscure or something, you need to listen to it several times again. It'll be there. So anyway, this is a website. So now let's see what we got here. So we're starting out with a simple project, a text finder project. Nobody's compelled to do it, but I think you'll get more out of it if you do participate, if you have the time and can. I know a lot of you are really busy at work and all that sort of stuff. The idea is that I've provided a little bit of starter code, and we'll build on that session by session. So first we'll build the text finder is broken up into packages, and we'll just build them one package for each session. I expect these sessions will be once every 2 weeks. Does that make sense for you guys? Can you manage a meeting once every 2 weeks?
Yep.
Yeah.
Yes.
Okay,
Yes,
good.
Professor.
Okay, and we've already talked about the Discord server. So so the process is we have these Zoom meetings, and on this one, I'm going to talk about some references and get started with Rust and try to go over more than just the basic ideas, and then at the end have a Q&A, and in meetings after that. My model is we won't start writing code until after the next session. That we'll spend the time between this session and the next one just trying to absorb as much Rust as we can. But after that, once we start working on these, when we're done with a package, I'll put my solution for the package on the website, and I'll put a link to it in the Discord server. So you'll all, if you want to, no obligation, but if you want to look at my solutions, you're welcome to do that. And so, those meetings will talk a little bit, tiny bit about my solution, then talk about, the next package coming up and so on. Here's the steps the way I've laid them out, and I'm going to try to combine session 2 and 3 in one session. So,
Excuse me, Doc. I'm sorry. Are you intending to share your screen?
yeah, did I not?
I don't see it. I don't know if anybody else
see
does.
it.
Well, you
I
guys
can see it.
I see it.
Yeah, we see it.
We
Yeah.
can see it. Yeah.
Okay, I'm sorry, Doc. I see it as well. I just wanted to make sure. I'm sorry to interrupt you. Thanks.
That's okay. Yeah, I'm glad you're, keeping on top of me. I did remember to start recording, so. But anyway, session 1 is now, and I'm going to try to combine session 2 and 3. It really depends on how well I describe Rust and how much you're willing to put into it before the next one. I'll survey you, but if it's okay with everybody, we'll just do these two together. In other words, in the next one, we'll kick off doing the first package from the text finder. And, I won't go, we'll go into the packages in a couple of minutes, just a quick survey. But we'll do text search and dirnav and command line parser, executive. And then there's a couple of extensions I have here with question marks, a regex extension and parallel text. This should be search. That's a typo. Mike, maybe you can make a note for me to put the C in search.
Yep.
And the question, I'd be happy to do it. The question is, will everybody's enthusiasm last long enough to get to those and work on it? And, if everybody is still interested, maybe we'll think about doing another project after that. There's just a little bit of motivation why I did it. Here, let's go to the build on. Can I move this bar over? Yes, I can. Here's the build on introduction. So I put together a page format just for the build on, and you can see what we're looking at is this build on intro. Then step 0 talks about the text finder as a whole, and then text search, directory navigation, command line parser, executive, and so on. And there's some references and a link to starting Rust. We're going to spend a fair amount of time talking about that today. And all of my stuff has a repository associated with it, and this link takes you to that build on repository, and it basically just says a little bit about it and lists the stuff. So that's the introduction. Here's the text finder. Let me move this panel over to my other window as someone had suggested to me. So, this text finder has a text search that just opens a file and checks to see if it contains some specified text. dirnav walks a directory tree, giving text search files that match a pattern, and text search will trigger displays of whatever it wants to do, whatever its functionality demands, and the executive reads a command line parser to get options. So that's the way it works. There's a specification for it, which I won't go through in gory detail. And there's some exercises for the coming 2 weeks. I'm sorry. These are exercises for after the second session. Let's go back to build on. There's some exercises here for starting with Rust. Before you do anything, look at getting started table 1A. That doesn't mean anything to you, but we'll see it in just a minute. And, so just things to look at and poke at a little bit on your Rust journey. And then there's some more exercises for the second session. Once we get into building the packages, no more exercises. The exercises are to build stuff, and you'll discover that I have a little bit of starter code. And actually, I've got quite a bit of starter code here. I'm not going to go over this. You can go over it and look at it. If you have questions about it, you can, probably the best thing to do is just save them until next time. But if you feel you want to, you can ask a question on the Discord server. Okay, so with that, let's go back. So we just looked at this. Now I want to look at the sitemap. So this, just about everything in this GitHub site has links on this page. So, there's quite a bit of stuff in this site, okay? And this just tries to organize it and make stuff accessible. I call this a help page. It's really a sitemap, but let me just take a minute and we'll take a quick look at the site design just so you have an idea of how it's laid out. The bulk of the content is code in a bunch of repositories, and there is a repository index for Rust, for C++, for C#, and JavaScript. And for each index, there is a whole family. For the Rust index, there's a whole family of Rust repositories. And, that's the way code is organized. And so what this is a documentation page for the code, and there's a link to it that takes you to the code. And these are stories. So a story is a connected sequence of web pages that tell a story. So if you go to the stories menu up at the top here, you'll see there's a C++ story, Rust byte by byte. We're going to look at a lot of these today. BuildOn, that's what we're looking at now, idioms and patterns, and so on. They're just connected sequences of pages that all focus on one thing. And so the bulk of what's here is code, stories, and a map that lets you find whatever you're trying to find. There's a little more information on this page, but let's just go back. And so we're back at the sitemap. And I am using right now these keys. I've set up keyboard commands. So, if you look at this site from, wherever you are on GitHub, your keyboard commands, as long as you're not using a tablet or a phone, the keyboard, if you have a laptop or a desktop, keyboard commands let you navigate around really nicely. I use forward and back a lot I got a couple of things I want to compare. I just, this is moving forward and back in the navigation. So let's quickly talk about each of these blocks and then let's start looking at stuff. So this first block, I've laid out a viewing order for Rust, really with this set of presentations in mind, but for anybody. And we'll take a peek at these in just a minute. And there's a starter trail, an intermediate trail, and so on. And then there is a Rust references trail. And I've highlighted three things. This first one is Rust documentation. Little Book of Rust Facts is official books. And almost everybody is advised to go look at the Rust Programming Language, the book. I lost patience with this book. It's nice, it's well written, but there's way too many words for far too little content. There's lots of little toy examples, but I just got totally frustrated with the speed it took to go through that. So I didn't use that much. Rust by example is interesting, worth looking at. The unofficial books, the General Introduction to Rust I like real well. That's a good one. And there's other stuff. And the intent here is that, you look at, you just click through these, take a quick peek sometime and kind of settle in on whatever it is you want to look at. The others are stuff from my site. There's a Rust story. And this is a narrative, it's a book, a narrative of chapters. And we're looking at that now. And if you click open, here's the chapters, a prologue we're looking at, models and data and operations and structs and libraries. And it does the same thing that the Rust site, Rustbook does, except that it goes faster, has more details, and you don't get frustrated with the slowness of your learning rate, So, and each of these, if we went to a chapter like libraries, for example, we open sections. This shows us all the sections of the library. So if you're interested in file system, just click on it, and here you are looking at file systems, and I've got an example, that I did, more than just the tiny little examples you see in the other books. So, I like that. And it's not too hard to, you just click on this guy, it'll stay open until you click it again. This is the sections of this page, and, and so on. And you can go, there's previous and next links that'll take you to the, previous page is a previous chapter. So let's go back to so that's the Rust story. The Rust bytes are little pieces of concentrated information about features of Rust. So if you look at the bytes, there's, an introduction that we're looking at, starting. Tooling you'll find interesting. Tooling helps you get going, setting up. I've got stuff for setting up Visual Studio Code, which I think you'll want to do, and configuring it to suit your work style and setting up debugging on it. And then, here's how you install Rust. Here's how you create projects. Here's how you create a library. Here's how you run tests and so on. So, that kind of information is in the tooling. And, just a bite on function. So it just talks about function syntax. So with that, let's go back to the site. And here's a list of all the stories and all the stuff in them. So for Rust story, here's his chapters. For the Rust byte, here's each of those chapters each of those bytes we were just looking at. The name Rust bytes come from learning Rust byte by byte, meaning you take a little bite out of the language and chew on it and digest it. BuildOn, here's all the pieces of the BuildOn stuff we were looking at. I've got a story called Idioms and Patterns that I'm just starting up. Sometime we'll take a look at it. And there's a C++ story if any of you are working on C++. That's there. Here's the repositories. You can get to every single repository just by clicking on one of these. So RustCom Experiments takes you to a synchronous message passing communication system that I built using the Rust TCP stream facilities, and so on. So there's repositories, and there's just other stuff. Here's the BuildOn PDF that we're looking at right now, and some different presentations, different videos. So that's what's there. Now let's take a look at this starting trail. First, I want to take a peek at a few of these things, and then we're going to look at start for probably most of the rest of the time. So here's start, and it just, getting started, and it's going to show you a little bit of code. We'll come back to that. And tooling, we just looked at, we'll come back to. Data talks about binding, copying, borrowing, moving, cloning, and mutating. And the way things are done in Rust is quite different than the way it's done in C++. Of all the languages, Rust is closest to C++, but this is a major departure, the way it handles basic data. And I'm going to talk about that a little bit today and a lot more next time. And one of your exercises is to look at this data. And facts just summarizes in a really condensed form a bunch of information about, the containers and all that stuff, smart pointers. And conversions. One of the things you'll hear is that Rust doesn't do a whole bunch of silent conversion for you. You need to do it, and so that's here to help you with that. Collections, I drew some pictures about the collections just to give you an idea of how they work. And there's a little bit of source code where we'll look at that kind of thing soon. Safety, we're going to spend a lot of time talking about that next time. This is the core idea. This is what makes Rust safe, the ideas that are here. And so we'll look at that next time. You're welcome to peek ahead. Error handling, options, all those things are nice Rust facilities. And Rust Lives is from my story. It just walks through all of the libraries. Okay, the standard library as a whole, collections part, standard I/O, file system, networking, threading, sync, async, and so on. There's a bunch of really nice things, times and dates. And I like the Rust libraries. I claim it satisfies the Goldilocks principle. Not too much, not too little, just about right. So, okay. I'm about ready to hit the start button and start walking through the ideas behind Rust. Anybody have any questions they want to ask before we start that? How's the pace, guys? Going okay?
It was
Yes.
a good introduction.
Yes.
Yeah,
Yes,
good.
Professor.
Okay, good. Nobody would admit for it to be. No one would want to say, "Oh, you're way too fast. Slow down." Okay. So the
Professor, I have a query over here.
sure.
Professor, one of the things which I was really looking into was to learn how to design proper systems or how to design proper code.
You'll see that not so much today, but you'll see it. For example, let me go back and let me go back to this. So, for example, in options, option is a particular structure, and I used option to build plugin architectures. And it turns out you need to. There's people, I've read people say you can't build plugin architectures. You can't do callbacks with Rust, and that's baloney. You can. And this shows you how. Babehab, if you send a request to the Discord server, I will put links to all of the architectural type things, okay, that I have. I don't have them all, but for example, I've got the dependency inversion principle is laid out here. If you go down to idioms and patterns, where did I put it? Yeah, dependency inversion, basic dependency inversion. This, the intent of this idioms and patterns is to write some C++, some Rust code, and some C# code. I'm falling behind on my C# code. But this shows you how to implement the dependency inversion principle. How do you build an object factory and an interface? Okay? You with me, Babehab?
Yes, Professor. So what exactly do you want me to do on this?
I don't want you to do anything. You said I'm interested in how you use Rust to build systems, and I'm saying, some of that material is here. There's a lot of it that's just Rust for Rust, but there's a lot of that kind of material here, and there'll be more coming as we go. Okay, and you'll be doing the same. You'll see that also just building the text finder. You'll run into some of the issues that you want to deal with. All right.
Thank you, Professor.
Yeah. And if you send me that link, I'll send me that post on Discord. I'll pick out the URLs for each of the things I think you might want to look at. Okay, so let's start. So Rust compiles to native code. Doesn't use a garbage collector, but the garbage collector was built in Java and C# to avoid unsound memory practice, unsound memory use. Double free, forget to free, dangling pointers and all that stuff. Rust does the same thing, gets the same effect without paying the penalty of a garbage collector. No garbage collector in Rust. It does it by checking the way you're using references. Everything that's indirect is a reference. Rust won't let you use raw pointers except in unsafe blocks you can, but that's not safe. And you shouldn't be using unsafe blocks. You don't need to. I've written a lot of Rust code, and I have yet to use a unsafe block. Okay, so compiles to native code, works safely with data without using a garbage collector. It has all heap memory is accessed through box T, which is a smart pointer, which the equivalent in C++ is a standard unique pointer. So, to me, I like working in Rust. To me, when I'm programming in Rust, it seems like I have a simpler C++ that has some of the C# features thrown in, and there's an oracle sitting at my elbow telling me anytime I'm doing something inappropriate from a memory safety or a data race safety issue. It won't build code that has memory unsound memory usage or data races. It won't build it. But it'll tell you what the problems are. And it does it with really clear error messages. Yeah, if you do something grievous enough, you can get it to give you totally meaningless error messages. But, that's only happened to me once or twice in all the Rust I've written. Almost always they're very sound, good, sensible error messages. They tell you, very often they'll tell you exactly how to fix the problem. They'll always tell you what the problem is, and a lot of the times they'll tell you how to fix it. There's some thoughts here about Rust's safety rules. Time is, marching on, so I'm going to skip over them for now. We're going to talk a lot about safety next time. Here's a little example of the use of functions. This is a little iterator and a factorial. And you look at this and you say, that doesn't look like a factorial. Where's the recursive descent? But you can do factorial with an iteration, and that's what we're doing here. And this is kind of interesting. We'll look at that in a minute, but the intent of me showing this is not that you understand it all, just that you look at it and you say, oh, okay, I can kind of see what's going on. Fn, that's a function, and it has a name, and I pass it arguments, and I pass it return types this way. And, so not too bad. And this is its output. There's this really nice facility called the Rust Playground, and that's what we're looking at now. And if I run it, I'm running that example. Let me see if I can make this bigger. So I just made it bigger. Now, let me look at this iteration. So you look at this and you say, here's where the factorial output. And you say, what the heck is going on here? Let me tell you, and then I'll show you. This is an iterator that starts from 2 and goes to I, and product is an iterator method, a adapter, if you will. Think of the adapter pattern in design patterns, kind of like that. You can chain these and decorate these guys with these. And so what product does is it keeps a running product, and at whatever number I get out of here, it multiplies that running product by that. But you say, if you look down here at the code, I'm going to start at 0. What happens when I start at 0? And I'll tell you, you get empty, and when product gets empty, it just multiplies its running count by 1. Doesn't make a change. Let me convince you that that's really what's going on. Come on. Thank you. So I'm going to uncomment those, and now let's run it again. And now we see, here's empty when I gave it 0, empty when I gave it 1. Now when I give it 2, it returns 2. When I give it 3, here, this is what it iterated. I'm just keeping track of the iterations, and then, that's the way it works. So Rust, there's a whole bunch of cool stuff in Rust. Now, you can always use this Rust sandbox if you just ask Dr. Google to give you access to Rust Playground. You'll get a screen like this, and it'll probably have a hello world on it, and you can write whatever code you want and run it. Now, the one thing, if you click that back button, your code is gone. You spend an hour getting code to work, and then accidentally click the back button, it's all gone. What you got to do is share it. If you share it, that'll give you the opportunity to make a perm link, which is stored somewhere, I don't know where. But now, when you do that, when it comes back, I'm not going to click on it now, but if I did, it would come back, and I could click on this, and it would put on my clipboard a link to that perm link. And then I can always get back to my code. Okay, so you can just keep OneNote or a Word page or your desktop or wherever, and just save those links, and you can always get back to them. Okay, so much for that. And I did the same thing for building an object. Now, Rust doesn't have classes, it uses structs, just like C++ uses classes. And you're going to look at these hard next time. And you're welcome to take a look at it, and it's not too complicated. And you look at it and you say, oh, okay, I can figure that out. And it's an interactive demo. We won't take the time to do that. And the other links I give you, this is a structs link, is to one of my bytes on structs, and it tells you, here's how that works. So, it's pretty easy. And the other one gave you links to iterators and options. Mike, I ought to put a link to functions here too. Would you make a note for me, and I'll put that?
Sure will. Okay.
Thanks. Okay, so the first thing you want to do tomorrow morning, reserve about 2 or 3 hours, make yourself a pot of coffee or tea or whatever your beverage of choice is, Jolt Cola or whatever, and go through these 3 things in this table. Rust intro, Rust in a nutshell. This, the text is a little long, but he's got a really nice collection of examples, basic examples that, in 3 different areas that show you a lot about how Rust does its thing. So really quickly, that'll get you up and going. Into Rust is a set of videos. They're really great. They use a book borrowing metaphor, and they're excellent. They were done by one of the main developers for the Rust compiler. And then Rust Survey, considering Rust video. This is a video by John Jengset, however you pronounce it, and it's great. If you're going to look at anything, look at this, because he gives you a really, really good idea about what stuff is all about. So tomorrow morning, you can go through this. If you start at 9 o'clock, by probably 11 or 11:30, you'll be done. And you'll have a really good idea of what Rust is. Okay, and some stuff to look at my site, but you can do that. I'll walk you through a lot of this stuff anyway. So what is Rust? So let's talk about what Rust really is. And I'm going to do that by talking about what Rust omits, mostly from C++, but a little bit from other languages. What Rust omits, what it changes, what it requires, and what it supports. Okay, Rust omits. There it is. I just didn't refresh the page. So it omits garbage collection. And it's some words about, how that works, and there's safety model and ownership model that get to the heart of that. It omits function overloading. There's no function overloading. Constructor for a Rust type, a structure, doesn't use the name of the structure. Unlike C++, it doesn't. Typically, they're new. or, but you can use any name you want. And so C++ added function overloading because they needed more than one kind of constructor, and the constructor has the name of the class, so that forced them to implement function overloading. It omits inheritance of non-static implementation. So in Java and C#, you can implement one base class and as many interfaces as you want. Rust chose to eliminate the base class. You can inherit as many interfaces as you want. And I have to tell you, you can do polymorphism just fine with this setup. I've done it, and I've gotten really happy with this. You can build the same kind of interesting domain-specific structures in Rust. You just do it slightly differently because of these. And these omissions almost always makes it simpler. So here is a playground example of that inheritance. So here I have a struct, and it just has a name string, and I'm implementing a clone trait. So trait is like this, an interface. It's trait, what C# and Java call an interface, Rust calls a trait, T-R-A-I-T. And clone is one of the standard traits, and I'm implementing that. And, you can figure out for yourself what's going on later on. We won't take the time to do it now. Here's a constructor. Here's new. Okay, so I've got a clone function. I've got new. Notice I implement clone for my type, and now I'm implementing the functions in my type. That's the way it works. Okay, and then main, we run it, and sure enough, original, my struct, and the clone. Okay. And you say, gee, that was too fast. I need time to look at it. You got all the time in the world. This is here. It's not going anywhere. Okay. After you're done Saturday morning with those three things, then during the week, come back and look at some of this stuff. And I've asked you to do that. Implicit conversion between types. All expressions must have exact type matches. There's a couple of places where Rust will do things implicitly. Two places that I know of. One place is if you're using a smart pointer, it automatically dereferences that a smart pointer so that you can call the interface of the thing that's pointed to directly without any dereferencing. You can just, on that smart pointer, you just use the interface, and it turns out to be quite convenient. The other place is, what's the other place? It slips me. It'll come to me in 5 minutes, and there's two small places where, yeah, there is a trait called deref, and if you've implemented deref for your class, or you're using a library type that's implemented deref, then if you have a pointer to it, you can pass it to a function that's, you can pass a reference to it to a function. You pass by reference, and the function will dereference it automatically if you've implemented that deref. But that's something for later on. Dereferencing raw pointers you can't do outside of unsafe blocks, and you're not going to use unsafe blocks. You can't do it. What does Rust change? Copy types and move types. Copy types are exactly those types with contiguous memory, so they're blittable, and that means the primitive types. It means all the integral types, all the floating types. It means literal strings, but not string class instances, just literal strings, the quoted strings are copy types. And arrays, all of whose elements are copyable, and structs, all of whose elements are copyable, and the same thing for tuples. Other than that, everything is a move type. And what that means is, if you say equals, let's go to the playground example. So here I've said x is 42, and by the way, I want its type to be I32. I could have said x colon I32 equals 42. I could have just said x equals 42. That works fine because Rust, in lieu of anything else, it will make an integral type I32 if you haven't told it to do anything different. So now I can say let y equals x. You can think of this as a copy construction. And what I'm doing is a blit. I'm taking all the elements of x and blitting them into y. All the bytes of x and blitting them into y. Now let v equals vex. This is a macro that'll build vectors for you. And I'm putting in integers 1, 2, 3. And I can print it. Now, if I say let w equals v, vector is a move type because it contains a control block on the stack and it contains all the values on the heap. It's not contiguous memory. So it's a move type. Almost everything is a move type except for the primitives and arrays and tuples and structs of primitives. Everything else is move. Now, once I've moved it, V becomes invalid. I can't use it again. This is a gotcha. It gets to a lot of people. Now, I could take care of that by saying v.clone. Let's do a little experiment. So here, let me, first of all, let me run this so you see that it works the way it is. Okay. Now, let's uncomment this. And now let's attempt to run it. And here's the compiler giving me, let me try to get this, make this a little smaller so we can, well, let me go to config and orientation vertical. Okay, good. So
But
now
you uncommented also the comment.
Yeah.
With 9, 10.
oh, yeah. Thank you, Murat. So, thank you. I did. So, my bad. Good. You guys are keeping on top of me. So now let's run it. And hey, now look, it told me, it said let v equal vec. Move occurs because v has type vec. That means it's a move type. And now let w equals v. Here's value moved here. It tells me where I moved it. And now it said, I'm trying to borrow this after moving it, and it's invalid. I can't. It's invalid. So the compiler's telling me exactly what happened. Now, when you first start Rust, you're going to get an awful lot of these. Oh, okay, that bad thing happened. Oh, okay, that bad thing happened. Okay, but once you have this idea and you put it in the frontal cortex, it becomes it just becomes second nature. It's easy. So copy types, only types of contiguous memory, they're implicitly copied. Everything else is implicitly moved. Move without you telling it to move. Move without you telling it to copy. Copy without you telling it to copy. Okay. Now, let me go back to that example. And let me uncomment this again. Now, let me say instead of w equals v, I'm going to say w equals v dot clone. Boily, it worked. Now, this comment says it can't display v because I didn't have the clone there when I wrote that comment, okay? But, if I have copy type, if I have a move type and I want to, I do something that would cause a move, I pass it by value into a function or I assign it to something, I can always create a clone and it'll move the clone and my original object stays valid. Now, Rust did these things. Rust built it this way because they made move implicit and they made clone explicit because they want you to know every time you do an expensive operation. Okay? Makes sense. So remember, this is a system programming language. Cool. So this is one of the two gotchas. Semantics for copy types and move types are fixed. You can't change it. Determined by the compiler. That's what makes it so simple. You're not writing you don't have to sit there and say, do I need to write a copy constructor? If all my data members have valid, in C++, if all my data members have valid copy semantics, I don't need to write a copy constructor. But if they don't, I do. You don't have to do that thought process in Rust because the semantics don't change. You can't write a copy constructor. You can write a clone, but you can't write a copy constructor. And that's good. At first, when I started using Rust, I wasn't so sure. I was going to say, I don't know, but I'm absolutely convinced. Rust supports deep clones and defines a clone trait that clonable types implement. You just saw us do that. Rust enumerations are cool. Let's look at this. So in error handling, here's an enum, a result type. I'm not going to talk about error now. I just want to talk about enumerations. So in most languages, elements of enumeration are just constant integral types. Integers maybe. Okay, that's all they are. That's all they'll ever be. But in Rust, they are wrappers for some type. They don't have to wrap a type, but they can. So here I have an OK of T, error of E, and the idea is in my result, if I have an error, I'll get as the return value error, that enumeration of result, and it contains something that tells me about the error. But if there wasn't any error, I get a T type, which is my result type, and now I can use it. I have to unwrap these, and we'll talk about all that, not today, but some other time. So enumerations are really powerful. And here I have, here's our playground example. So I have an enumeration for step state. That's our steps in BuildOn. So step state is not started. I'm reading, I'm writing code, I'm finished. So not started doesn't have anything, doesn't wrap anything. Reading wraps a vector of strings. These are the things I'm reading right now. And writing contains a single string, which is the package name that I'm writing. And satisfied is a number from 1 to 10 that says how satisfied I am. On a scale of 1 to 10, how satisfied are you with the code you just wrote? If it's 3, maybe you want to redesign. But anyway, and so, I'm just creating an instance of each. And now there's this nice match capability, match S. So here I set S to S2, match S, and it will pick whichever one matches. So S2 is reading, so it'll match reading. So let's run it. Reading, Rust bytes getting started. Okay, and if I change this to S3, writing text search. Okay, so Rust enumerations are cool. They work really, really well. Rust iterators are very similar to C# iterators. They have a next function, but they don't return a null, they return an option. And option. So an option has some of t or none. So the iterator, as it's iterating, as long as it has something to return, you're iterating over a list of integers or something. If it has something to return, it returns it in sum. When it gets to the end, it doesn't have anything more, it returns none. So no nulls, no null references, no null pointers, no null exceptions. Just either some or none. How we doing, guys? No?
Good, Professor.
I'm trying to understand the syntax and
Yeah, sure. So my advice is don't get too hung up. This isn't going anyplace. It's here forever. You can come back to it. Okay. So, and there's lots of material that goes into, you go into some of these Rust story iterators, Rust iterators, it's all laid out. So, we just don't have time to follow all those links. So, but the iterators have a whole family of adapters. Strings are a very special case, as we'll see later on. Rust strings are UTF-8 strings. What that means is that each character, UTF character, may have from 1 to 4 bytes. And so they occupy different sizes. That means you can't index a Rust string. The iterator is smart enough to know there's byte sequences that determine the boundaries of a UTF-8 character. And this char's iterator is smart enough to detect that. And so it just moves character by character. If it's 1 byte, great. If it's 4 bytes, great. If it's 3 bytes, great. It knows enough to do that rationally. And now, if I want the third character, I can just say iterate over chars.end. And it doesn't sit here and iterate over all of them and then give me the third one. It just starts the iteration and is calling this each time. And when it gets this, it quits. It does a lazy iteration. It doesn't do any more than it has to. Okay. So those are things that Rust changed. Now let's talk about things that Rust requires. Rust requires explicit declaration of mutability. Let mut x equal 42. Let a reference to x be reference mut x. This is the syntax you use. Okay. You can say, gee, none of the other languages make me do that. Well, blah, 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 blah. But Rust's model is safety first. I don't want you to write some code that you think is unchanged because you didn't change it, but your colleague who's writing code for the same process went and changed it. So if you declare it as mutable, you're saying, I know this can change. If you don't declare it as mutable, you say, I know it can't change, and the compiler won't let you change it. And, probably I get more compiler errors over mut because I forget to put it in and use it. And, the compiler just nicely says, you want to, please add mut here. You add it in, you go away. Okay, you go on with your thing. There's a process. When you start to do A at the beginning and later on, when you start to do some complex things, like, for example, the plugin architecture that I wrote, the ideas are a little bit complicated, and you'll discover that you'll get a lot of compile errors. And what you want to do is work off the first one and then recompile, because sometimes you get 3 or 4 errors, and it's just the first one triggered. The others are bogus errors. The first error triggered it. We've all seen that with C++. I think that may happen a little more with C#. So if you compile it and your whole page gets littered with these errors, don't worry about it. Just go fix the first one and recompile. And what you'll find is you'll do that once or twice or max 3 times and you're all done. It's all cleaned up and away you go. Okay, the other main gotcha is no concurrent aliasing and mutation with references. You can't. So one way of saying it is a Rust program cannot read or write to a memory it does not own. And a nearly equivalent statement is that Rust will not change the contents a reference points to unless the reference is mutable and responsible for the change. If I have a mutable reference into an element in a vector, Rust won't let the vector mutate until that reference goes out of scope. This is a very strong condition, and it gives more people trouble than any other single part of. This is what makes Rust safe. This is what handles all those pointer problems you can get into with C++ without a garbage collector. C# made them all go away with the garbage collector, or Java made them all go away with the garbage collector, and C# copied it. This is responsible for that. And you say, hey, I want to build a graph class. And I've got a node, and it has 2 parents, and they both may want to mutate it. I can't build a graph. And that's wrong, I can't. But I just can't build a graph using references. What I can do to build a graph is I create a vertex, a vector of vertices. I move all my vertices into the vector, and I make those parent-child relationships with indexes. And that's fine. Indexes aren't subject to this because they're not pointers. They don't get invalidated. When somebody pushes onto that vector another vertex, causing it to reallocate its memory, all the references would become invalid if that were allowed to happen, but indices don't become invalid. They're just from wherever that memory moved to is just offsets from that memory. So I can build a linked data structure using indexing really easily. Several years ago, I built a data class in C++, and I used exactly that vector of vertex issues because that's the only way I could make it work safely with C++. C++ wasn't forcing me to do it. I forced me to do it because I could see lots and lots of data problems coming. And so the upshot of this is you are not going to build a linked data structure with Rust. Forget about it. But you can do the equivalent with indexing in a vector. We're going to talk about this a lot. If that puzzles you, we'll talk about it again. Next time we're going to talk about safety, and I'm going to show you some pictures and talk about it much more. So
there is one question, Dr.
Sure.
Fawcett. It says, what about index out of bounds exception?
Here's what happens. So Rust can't be. Rust checking is compile time checking. Most of it is. It cannot prevent you from stepping off the end of the array with a compile time error because that's a runtime condition. But what happens is you can step off the end of the array with Rust, but you cannot read or write that memory. With C++, you step off the end of the array, you can read and write that memory all you want. But in Rust, what happens is if you step off the end of the array, it does what's called a panic. It does an orderly shutdown of that thread, and you never get a chance to read or write the memory. So panic is a very bottom-level safety mechanism that says you're not going to read or write to memory you don't own. You can step off the end of the array. That's a logical error, and your program won't work correctly. It'll panic, but it won't silently read some bogus data, filter it in your program, and your program runs for half an hour on this bogus data, and you sit there, and it ends normally. The C++ process will end normally, and you look at it and say, these results don't make sense. Where do they come from? And you'll never find it. But here, bingo, panic, you got it. Okay? One thing that Rust does is all of the indexable types, the native arrays, vectors, all that stuff, anything that can be indexed has a length measure, and Rust tracks that at runtime. The one thing Rust does at runtime is it tracks you indexing operations to make sure you don't go off the end of the array. And if you do, it panics.
So does the panic is some kind of crash or something, or it just some
No, it's an
crash
orderly
related?
shutdown. It's like in C++, an unhandled exception. That isn't a crash. It just shuts the program down.
And how do we get the information about which thread has the
You
panic or
can get
something?
that information. Normally, you don't ever have to get it. Indexing off the end of the array is something you don't ever have to do.
Mhm.
Just like C++, Rust has what amounts to a range-based for loop. You'll never step off the end of the array with a range-based for loop.
Yeah.
And it has all those mechanics. So, you won't write code to do that. You got to try really hard to get that to happen.
Yeah.
Okay.
Yeah.
But nothing bad happens if you do.
Mhm.
Nobody can read, no vulnerability because I allowed somebody to step off my array and read, it gave me some input that forced me off the end of my array because he analyzed my code really well. And now he's injecting into my code a jump to some malicious code that he wants to run. Okay.
Yeah.
So, anyway, that can't happen in Rust. Hang on a minute. 1 second. I'm diabetic. My blood sugar was going a little high. I had to give myself a squirt of insulin. Okay. So references may not outlive their referends. And normally this all happens silently. You don't see it. You don't do anything with it. But every once in a while, the Rust borrow checker, the guy that checks references, analyzes the reference lifetime and refuses to compile cases where it can't prove that invariant. Now, there are a few cases that get complicated enough that Rust can't analyze it. It can't prove it, although it won't happen, but it can't prove that it won't happen, and so it'll fail the compile. But it'll tell you need to annotate the lifetimes. Let me show you. I'm not gonna teach you how to do it, but let me show you what it looks like. Here, I have a structure that's taking a plugin. This is the plugin architecture I was talking about with. And the issue is, I got to make sure that that plugin doesn't go away, doesn't go out of scope before demo quits. Or I'll start making calls on a plugin that isn't there. And so what he does is, this tick A is the name of a lifetime. It's done with, lifetimes are managed through the syntax of generic parameters. Tick A, tick anything is a lifetime, name of a lifetime. So demo is saying, this is my lifetime. And now he's saying the T that I use, that's the plugin, the T is the plugin. The T that I use has to satisfy the plugin interface and debug, and its lifetime must be at least as big as my lifetime. Now, that isn't changing any lifetimes at all. It's telling Rust, here's what you got to check for. So should I arrange things so that my plugin goes out of scope before demo does, it should fail to build. Not because Rust can't analyze it, but because there really was an error in my design. Okay, so, we'll talk about that some other time. I've got you. There's lots of resources to look at, but all I'm trying to do is to give you a flavor. Here's Rust. Here's really what Rust is. You know, by the end of the day, you're not going to be a Rust ninja, but you're going to have common sense about Rust. My goal for you is that you have common sense about Rust at the end of the day, and then within a couple of weeks, you start to approach ninjahood. Okay? All right. Only one owner of data. C++ really does that. There isn't much difference between, this is the RAII, this is, I manage my resources based on my scope. When I go out of scope, I drop all my resources. And really the languages, the only languages that don't have one owner of data are managed languages like C# and Java, where the garbage collector owns everything. Your class doesn't own anything. The garbage collector owns it because the owner is the guy who releases the resources.
And Doc, if I may, a question for you. That includes cases where when you're passing instances of objects around, those are explicit ownership transfers. Once you pass it to a function, for instance, that function owns it and it's no longer valid when you return from that scope, right?
If I pass it by value, that's true. If I pass it by reference, it's not true.
Right.
And we'll get into those things, but okay. All access to heap storage uses a smart pointer box of T. And, you know, here's a little example, playground example. So here I have a vector and I wrap it. I put an instance of that vector on the heap. Really, this is what I did was I moved V. Mike, was it you that asked that question?
Yes, it is, Doc. Yeah.
So here I moved, this V is moved into the box because this is taking it by value. So I just moved my vector V into the box. Okay. And now I display it, VB. Okay. I'm displaying it. Let's run it. So here I displayed it. That's what's on the heap, 1, 2, 3. And now I say VB, I'm talking to the box, VB.push. I'm using V's interface. Remember I said that some functions implement deref, and so smart pointers particularly, on a smart pointer you can use the interface of the thing pointed to. That's exactly what I'm doing here. VB is a smart box pointer. This VB stands for box vector. And my box vector, I just call push, which is a V function, not a VB function. The box has no function push, but V does. And so the box just dereferences that. He's got a pointer to that guy, and he dereferences that to allow me to push it. And you can see it pushed that onto the heap.
Can you go back to the example path again?
Go back to where we just were?
Yeah, the same example. So on line number 2, you're creating a vector V, and that is not mutable, right? So basically that's a constant, right? If I understood it right. And
yep, but here I said, so here, see, what I'm doing here is, now this is a new thing. I moved V into box. And here
okay.
I'm saying, box, you're mutable.
Okay.
Okay. And since this is his now, that makes that part of it mutable because he's mutable.
Okay. And you won't be able to access anything out of V because V doesn't have anything now.
I couldn't change V here.
Okay.
But you know, I'd have to do it before this statement because this statement moved it into the box.
Okay. Makes sense.
And if you try to use V after that, Doc, it just won't build anymore, right? Because V is invalid.
Yeah, so, it'll just say been moved.
Yeah.
Yep.
Here's a long-winded thing. Function invocations on generic type T require a type constraint on T. This is exactly what Java and C# do. all this is really saying is if so, RT is an object of type T. This is a generic. It's my name RT is a reference to this T type, so it's a generic. And to make a call on that generic thing, I could not make this call clone unless I told it T implements clone. C# constraints work just like that. Java has the same kind of thing, if I remember. I haven't written Java code in a long time, but if I remember, Java is the same way. Okay, so if I want to call, now C++ doesn't do that. C++ would be perfectly happy to let me compile that. Now when I instantiate it for some type, if it didn't implement clone, then it would fail to compile. This will fail to compile before I ever try to instantiate it on some specific type. It does an eager syntax analysis, and C# and Java do an eager syntax analysis on the generic parameters. C# does a lazy one. It lets you compile the generic library, and if you don't give it a type that satisfies what it needs, then it'll fail to compile. But this does it eagerly, just like C# and Java. It's no different. So here, demo, this is my demo function where T equal clone. This is just exactly the code that I had here, and you can see it works. Okay. Rust supports. So now we're done with the requires. Here's all the hard stuff that Rust says, in order for me to ensure your program is memory and data erase safe. And we haven't I haven't said anything about why it's data erase safe. You won't see that until if we do the extension for parallel searching, then we'll talk about that. You know, if everybody wanted to hear about it sooner, we could just set aside one of these and just talk about that. But it would take us pretty much the whole session to talk about it. Okay. So now Rust support. So here's some goodies that Rust adds. The result and option we've already talked about. And there's some links over here. Rust strings are collections of UTF-8 characters, which may have sizes from 1 to 4 bytes. So that means that the strings I can write Arabic scripts or Sanskrit or Hanzi or Kanji or whatever, any of those things. What's the Turkish language, the primary Turkish language called? Turkish? I mean, there's a script.
You're muted, Murat.
I am sorry. It is just Turkish.
Okay.
It has a couple of additional letters to the European letters. I mean, we have 4 or 5 on top of the European letters. We are using Latin alphabets.
Oh, okay. All right.
Mm-hmm.
So I would write over here. I would write Turkish.
Yeah.
Because without that you can't use the diacritics and the umlauts and all that stuff. So, not that I know anything about that. I don't know anything about that. I'm just making this up as I go along.
ASCII suffered many people a lot. I mean, so UTF is good.
So anyway, the good news is that you can represent anything. The bad news is you can't index the strings because the characters are of varying sizes. So you got to iterate over them, and that's an order n operation. Now, there are some things you can do, if you have a really performance critical application and you're willing to insist that everything is ASCII characters, you could represent your strings with byte arrays and do a little tiny bit of conversion, for the display, and that you could do it. Rust has an OS string so that it can use the foreign function interface and talk to C, for example. So OS compares to string. String also has a, I didn't put it here, but it has a literal lowercase str, this guy right here. Okay, so the normal Rust strings are this string, and this is a string with characters on the heap and a control block on the stack. This is a literal string with characters on the stack in one contiguous block, so it can be copied. But it can't be edited. And you can't put it in an array. You know, I can put an array of these. I can put strings in a vector, because what I'm really putting in there is control blocks, and the control blocks all have the same size. But these guys are all different sizes. You know, ABC is a different size than ABC 1, 2, 3. So I can't put them in a vector or an array. So there's OS string, and there's a corresponding OS str, which is a literal version. This is just a platform string. On Windows, it's Unicode, and on Mac OS, it's whatever Mac OS uses. It also provides path buff and path, which you're going to use. They wrap these guys. You're going to use them when you build the dirnav. In fact, you'll use them a little tiny bit in the first thing you build, the text search, because you have to open files and you got to specify a path. But that's really easy to do. Mike?
Yes, Doc.
Yeah,
I'm here.
would you make a note for me? I want to make sure that I put references to the path and path buff to examples for, I don't think I put them in step 1, which is the text search. They'll need it for that. So I just need to add references for
Sure thing.
that they're easy to use and easy to convert. Panic on integer overflow or underflow in debug mode. So this isn't reader and writing memory you don't own. It's just you're indexing, maybe a byte, U8, and you index it past 255. It rolls over, and in debug mode, you'll get a panic when that happens. That's expensive. So in release build, it doesn't do that checking. So the assumption is that you've exercised all your tests thoroughly in debug mode before because it's not going to do that checking. There may be a way to make it, but that's expensive, and so they don't want to do that in release mode. Panic on integer, so we said that. Function and type declarations may be ordered without concern for dependencies. That's like C# and Java. C++, you have to have definition first. You can't use something until you've defined it. In Rust, I can define a struct that uses a function and define the function below the struct, and that works fine. And Rust can generate WebAssembly. I haven't done any of that yet, but I'm itching to give it a try. So, but hey, this is Rust. You've just gotten a taste of all of Rust. Are you a ninja? No, of course not. But you've got a taste. There's nothing, I didn't leave anything out. I've been writing Rust for a year. Here's the Rust code I've written. I've written quite a bit of Rust code. And there's nothing in the code I wrote that isn't on this sheet somewhere. So that gets your arms around it. Now, the next thing you want to do tomorrow morning, I want you to promise that you'll sit down with a cup of coffee and look at these 3 things. This is a set of little examples. Sometimes he talks a little too long in places, but there's nice little data examples, really, really nicely done. And this is a set of 5 short videos. Each video is about, I don't know, 6 or 7 minutes long. Really well done. And this is a wonderful walkthrough by a very smart guy through Rust. Really does a nice job of telling you about what Rust is. Okay, so let's see where I am. So we've been through start, we've done a peek at the items, let's look at the tooling and the Rust lives just for a minute. So tooling, we already looked at, is this page. And what you want to do is set up, you don't need to do it immediately, but soon, before you do any of the BuildOn coding itself, you need to set up the Rust environment. It's really simple. To install Rust, you go to the Rust website, you download it. In 5 minutes, you have everything you need to build Rust from the command line. There's a beautiful tool called Cargo. I talk about it a little bit in this tooling. And Cargo creates packages for you, creates, if it's Rust calls it a binary, it's an executable console application. You can do that. You can build a project that builds a library. I'll reserve. There's a whole bunch of stuff to talk about. But I'll reserve it to next time. I'm getting a little tired, and you're getting tired of listening to me. So, so I think you want to use Visual Studio Code. Really nice for Rust. What I do is I don't. It has a run, and but I just do all my command line in the Visual Studio terminal right here. I'll just say Cargo run, and it builds it and runs it. Just like clicking the run button in the playground. So, for a few days, the playground is just fine, and you get to the playground really easily. All you got to do to get to the playground, all you got to do is say, Dr. Google, please give me Rust playground. There it is. And now you can type in anything you want. You can go and scrape my screens, select right off the screen, paste it in here, and it'll work. Okay, so.
Dr. Fawcett, I have another meeting just coming up. So
Yeah,
thank you for your time, and hope to see you in next meeting.
Good, yeah, Murat, I'm delighted you were here. We're about wound up anyway, and so, if I say anything miraculous between now and then, I'll leave you a little note on the Discord server, but I doubt that'll happen. Okay, have a good meeting.
Thank you very much. Have a good weekend, everybody.
Thanks, Murat. Oh, come on, let me kill this guy.
Likewise, Professor, I have another meeting to join as well. So I look forward to attending the next session. Thank you.
Okay, was that Simuk?
Oh, no, Vishtas.
Oh, Vishtap. Oh, I didn't see you. Put on your video just for a minute before you go. Hi, Vishtap. Everybody, this is Vishtap. Vishtasp. And it took me for a long time to remember to put the ASP on his name, but
Yes.
okay, have a good meeting. We'll see you next time.
Thank you, Professor. See
Okay,
you.
bye-bye. Okay, we're pretty close to wound up here, so. So next time, so I want your, not now, but during the next 2 weeks, so we'll meet again in 2 weeks. I would like your inputs on the Discord server about, we're ready to start building the text finder, or no, we need some more time to look at some of the rough details. You'll probably feel like you need some more time, but if I can convince you to just dive ahead and dive in, that really turns out to be a good strategy. When you learn is when you first start trying to do something really useful, and then the rubber hits the road and you learn like crazy. So, upcoming sessions. So that's all. Alrighty. So, are there any questions before we go? We all good to go? Arpit, you good to go?
Yeah.
Yeah.
Okay. Neeper, how we doing?
So far, so good.
So far,
It's a little.
okay, good. So, and hello, Brandon. Hi, neighbor. It turns out Brandon's
Hey, how are
my
you?
neighbor. I didn't know he was, but he is. So,
Yes,
so
big
other
surprise.
people. Dan, turn on your screen for a minute so we can see you. Hi, Amit. Good. Maybe he's not listening or gone, but anyway, so again, Discord server is all about people getting together, working together, chatting with each other. You can ask me questions, but with this many people, I'm not going to do a very good job of answering every single question. I guarantee you that I won't. I'll answer a few, but feel free to answer each other's questions. Vaibhav and Mike and all you guys, Simuk and who's working on Rust right now? Is anybody?
Me. I'm working on Rust right now.
Zing?
Yeah.
Oh, hi. Can you turn on your screen so we can see you?
I don't have a webcam.
Oh, okay. So, did this presentation make sense for you?
Yes, very cool. Like you present the very core idea of the Rust. I think it's very cool.
Okay, good. So there's a guy that's working on it now, and I hope you have the patience to stick through all of this with you, because I'll be glad to get your feedback.
Yeah, cool. Of course.
All righty, great.
Mm-hmm.
Okay, guys, I think we're ready to sign off, say sayonara. So I will send out another notice. I plan on meeting again in 2 weeks. How's that time interval sound? Is it okay? 2 weeks is a reasonable time? Okay. So I'll probably send out another Zoom link for in about a week, saying, a week further, here's the time and date. Does this time and date work good for everybody? 3 o'clock or 2 o'clock Friday afternoon?
Yes.
Works for me.
Okay. If there's anybody it doesn't work for, or anybody would like a little change, you're welcome to submit a request on the Discord server. And is everybody? I know everybody isn't on the Discord server, but a lot of you are. If you're not and you don't know how to join, send me an email. Either my Time Warner email, the one you're used to from the university, or the Code Collab email that I sent everybody. You can send me a request, and I'll do what I can. We got to do what works for everybody, but if a time change or something like that works good for everybody, we can do it. All righty, I'm
Professor?
done. So we'll see you all. Have a good 2 weeks. Stay healthy, and we'll see you real soon.
Thanks, Doc. Appreciate it.
You're welcome.
Thank you,
Professor.
Professor.
I just got
Thank you, Doctor. Bye-bye.
Bye-bye. I got to figure out how to get out of here. So I got to stop
Professor, what about the recordings?
I just stopped it. So what I'm going to do is, if it's small enough, I'm going to post the recording to GitHub, and that'll be a day or two. If it's too big to fit on GitHub, then Mike has an editor, and he and I will edit it down to size. Get rid of some of my rambling so it's small enough to put on GitHub. And when I have it on GitHub, I don't mean GitHub, I mean YouTube. When I have it on YouTube, I'll put a link on my website and I'll put a link on the Discord server to the video. Okay? So if possible, that'll be up in 2 days. All righty, guys. We'll see y'all.
Bye bye.
Thanks, Doc. See ya.
Steve.